Assalamu alaikum students. Article for today is there is no article basically. We are going to discuss some assignments given in your book and some examples as well. So starting with the assign example 2. So according to the figure given, we see that F1 force of 15 Newton is in making an angle of 70 degree with the x-axis, and there is another force that is F2. It is making an angle of 220 degree with x-axis, and we have been asked to find out the resultant force, that is Fr, and also the angle which is it is making from the positive x-axis, that is we have to determine theta r. So to find it, what we will do, that we will go for the resultant force, which is equal to frxi into fry into j. So first we will calculate the x components, then we will go for y. So for rx we are having f1x plus f2x, and we see that this after adding both of the x components for the force f1 and f2, we will get frx. So firstly we will calculate f1x, which is going to have the formula f1 cos theta 1, and putting the value of f1 and theta 1, this is going to be 5.13 Newton. Now talking about f2x, we putting the value of f2 and theta 2, we are going to get minus 19.15 Newton. Lastly, we are going to calculate fx, which is going to be f1x plus f2x. This whole sums out to be minus 14.02 Newton. Coming towards the y components, fry equals to f1y plus f2y. First we will calculate f1y, and the value of f1y would be equal to f1 sine theta 1. Putting the values, we get 14.09 Newton, and then f2y equals to f2 sine theta 2. Putting the values, we get minus 16.07. Now taking the sum of these two y components, we get fy equals to minus 1.98 Newton. Now taking out the magnitude, for that we use fx square, the magnitude formula, that is the Pythagoras one, fx square plus fy square. Putting the values, we get 14.6 Newton. This shows that the force which we are calculating, it is having the value 14.16, but we observe that the x component of force, it is having a negative sign with it, and the y component of force, it is also having a negative sign with it. So we see that when both the fx component and fy component, these both components are having a negative sign, so that means the resultant lies in the third quadrant. So this is the condition, like theta, which will be, and you can see in this figure as well that the resultant is lying in the third quadrant. So we will use the equation for the third quadrant. So firstly we will calculate the value of theta, which is tan inverse of fy over fx. This comes out to be 7.97 degrees, but since it is lying in the third quadrant, so we will use the equation of third quadrant, which is 180 degree plus theta, and this comes out to be 187.97 degrees. So this is the value of theta r, which we want to calculate. Coming towards the next question, like if I see, so this is extension exercise of related to example 2.2, and this is the first part of this, in which we have to calculate the resultant force when f1 minus f2 is the condition. That means f1 would remain the same, but the direction of f2 would be reversed. So f1, we have drawn this f1 as it was earlier drawn, and now the direction of f2 was like this previously. Why? Because we have to calculate the resultant. For that we need to draw the vectors according to head to tail rule, but here we are not going to do this. We are going to draw our vector as it was drawn, such like that the direction of f2 would be in the third quadrant, right? So if f2 is in the third quadrant, and if I draw the anti-parallel vector of f2, then the direction of f2 can be drawn like this, right? So f2 is now is in the opposite direction. This you can say is minus f2. And now the angle, talking about the angle which we are having, now we I know that the angle for this would be taken as 40 degree. How can we say that this angle is of 40 degree? Consider this is the condition, and this is f1, and this is f2, right? And what about this f2? If I want to, if I really want to draw this, I will choose the angle with the x-axis. Now we know that the whole of the angle earlier that it was having, consider this is complete 180 degree, right? And this was, I don't know about this angle, right? If I say this is angle theta, but I knew earlier that this whole angle that f2 was making, it was equal to 220 degree. So what I'm going to do, I'm going to subtract 220 degree, and from this 220 degree I'm going to subtract 180 degree. So what angle I'm getting? I'm getting angle equals to 40 degree. So this theta, this is equal to 40 degree, right? So if the theta is in this condition, it is 40 degree, then the angle which we are having over here is also going to be 40 degree according to the alternate angles. So yeah, in this regard, what we see that for f2 we are going to put an angle of 40 degree. Now again the procedure would be the same. F1x, we have to calculate f1x, f1 cos theta, and accordingly putting the values, we get the value equals to 5.9 5.1 newton. Then calculating f2x, the value is 19.1 newton. Then f1y, the value is 14.09 newton. And then f2y, the value is 16.01 something newton. Then after adding f1x and f2x, what we get, we are going to get the value 24.2 newton, and after summing up f1y and f2y, we get 30.09 newton. Now taking out the magnitude of this using this particular formula, we get the value equals to be 38.6 newton. And to calculate theta, okay, here we see that both the x component and the y component, these are having the positive signs with them, like fx and fy both are positive. So the vector lies in the first quadrant. As you can see, the vector also here is in the first quadrant. So theta would be equal to theta r, and theta can be calculated as tan inverse of y component over x component, and the value comes out to be 51 degrees. That means the resultant which we have drawn here, like if the resultant is, suppose this is the resultant, so the angle which we are having over here is 51 degree. So we are talking about this particular angle. This angle is basically 51 degree, right? So that's how we can solve our this extension exercise. Now coming towards the second part of this extension exercise, as you can see that we have to now do the same thing, but with the interchange stuff, like f2 minus f1 we have to draw. So in this regard, we see that the data would remain same except for theta 2, sorry, except for theta 1 in this case. Like f1, I have drawn f1 in the same way which I have drawn earlier, f1 or with 70 degree angle. Then f2 is also drawn with an angle of 220 degree with the x-axis. Now you see that if this is the f2 vector, and if I definitely have to draw an anti-parallel vector of f1, because it is now having a direction a minus f2. So in that regard, I will draw this f1, this is f2, and I'm going to write it like this is minus f1, right? And this minus f1, now talking about its angle, how we can draw this particular vector at some angle. For that, we should understand this thing that if this is considered to be um, the x-axis, then this angle is equal to 70 degree, right? If this angle is equal to 70 degree, and this whole angle is equal to 180 degree, then 180 degree plus 70 degree. So in this regard, we see that this whole angle would be equal to 180 degree plus 70 degree, which is equal to 250 degree. So I'm going to put the value for f angle for f1 equals to 250 degree. If I solve it with 250 degree, how we are going to solve it? So in this regard, we see that for f1x we are having the value minus 5.1 newton, f2x we are having minus 19.1 newton. Summing up both, we get minus 24.2 newton. Then f1y minus 14.09, f2y minus 16.06, then fy, that is the sum of both, will be equal to minus 30.15 newton. Taking out the magnitude of the forces, this is 38.6 newton. And after that, if I really want to calculate the um, uh, theta, this theta would be equal to 51 degree. So this theta was the same which we have calculated earlier. All the values are same except for the condition that f1 and fx and fy both are negative, so the resultant would lie in the third vector, and as you can see in this figure, that the resultant is lying in the third quadrant. So we will use the equation of third quadrant, which is 180 degree plus theta. So 180 degree plus 51 degree is equal to 231 degree. That means our resultant is making an angle of, up till here, it is making an angle of 231 degrees. Now moving towards the next question, which is assignment 2.2, and in that, so this is the next thing, the next example, which says that we are having a vector which is f1, and it is like it is making an angle of 30 degree with the x-axis, as you can see here. Then there is f2, which is making an angle of 70 degree with the not 70 degree, you can say 150 degree from the positive x-axis. So these two angles we have drawn. Now if I want to add these two vectors, f2 has to be drawn over here so that we can add up according to head to tail rule. Then resultant is drawn, which is shown by this. In this case, you have to see that the magnitude of f has to be calculated and theta r has to be calculated. So f1 fr can be calculated if we know the resultant. So to get the resultants, f1x would be equal to 17.32 newton, f2x using the same formula as f2 cos theta 2, putting the values we get minus 25.98, f1y to be 10 newton and f2y to be 50 newton. Taking the sums of the x components, we get minus 8.66 newton, and taking the sum of the y components, we get 25 newton. Now here we are going to get the magnitude. To calculate the magnitude, after calculating the magnitude, the value which we get is 26.45 newton. And talking about the theta stuff, theta equals to 10 inverse of fy over fx. I'm going to put the value 25 over 8.66. Now you must be wondering why I'm not putting minus over here, because the reason for this is we already know that the vector is lying in the second quadrant. So that obviously means that it is having an angle of it is making an angle in the definitely in the clockwise direction. So 70 degrees is basically the angle which is drawn in this particular direction, right? So we already know this is a clockwise angle, so no need to put a 7 minus sign over here. So if we calculate, because that sign would definitely be changed into negative sign when it comes to the final equation. I'm talking about this one. So theta equals to 70 degree, and now we know that fx is negative and fy is positive. So vector lies in the second quadrant, and we are using the second quadrant equation, which is 180 degree minus minus theta. So now if you can see, the value of 70 degree is having a minus sign with it, and ultimately theta r is equal to be 110 degrees. And as you can see in this figure, that this angle is surely be observed to be of 110 degrees. Okay, now moving towards example 2.3, in which theta 1 is the angle, like there is a force which is along the x-axis. So f1 is along x-axis, so it is having an angle of 0 degree. And there is another force f2, which is having an angle of theta degree, because we don't know that how much angle it is making with the x-axis, or you can simply say with the f1, because f1 is also along x-axis. So we don't know this angle, so theta 2 is going to be equal to theta, which we are going to find out. Now the question is that if the magnitudes of these two forces, that is f1 is equal to f2, and the magnitude of both forces is equal to the magnitude of the resultant as well, then what is going to be the angle between f1 and f2, right? So this is the question. If I see that f1 is equal to f2 is equal to fr, and I have taken a general symbol for all of these, which is f. And we see that the angle between f1 and f2 is still unknown, so I'm going to put theta in this regard. And now using the same condition, that f1 is equal to f and f2 is also equal to f, and for f1 we are having theta equals to 0 degree, so f1x equals to f1 cos theta 1, and the value of f1 is f, the value of theta 1 is 0 degree, so the answer would be f. Now for f2x, the value of f2 is again f, and the value of theta 2 is not known, so I'm going to put the value equals to theta, so this value comes out to be f cos theta. Now f1y is equal to f1 sine theta 1, which is equal to f sine 0 degree. Of course theta 1 is equal to 0 degree, so we get the value equals to 0. Now f2y, which is having an angle theta, so the value comes out to be f sine theta. Now adding the x components, it will become f plus f cos theta, and adding the y components, we get f sine theta. Now taking out the magnitude would be equals to fx square plus fy square under the root, and we are going to put the value there. This would be the square of, like, whole square formula, a plus b whole square. When we open it, we get f square plus f square cos theta, cos square theta, and 2f square cos theta, and here we are going to get f square sine square theta, simple square. Now we see that there is a cos square theta factor, and here we are having sine square theta. We are combining both of these, and this is an identity which is equal to 1. So putting the value equals to 1, what we are finally having f square plus 2f square cos theta plus f square. Now this f square and f square would be added, and we get 2f square plus 2f square cos theta. From here we see that we are having f square and f square, so taking that common and out of this under root, so ultimately what we see, f is going out and it would be cancelled out on both sides. Rest of the value is under root 2 plus 2 cos theta. Taking out the square on both sides, what we finally get, 1 equals to 2 plus 2 cos theta. Taking 2 on the other side, we get minus 1, so minus 1 by 2 equals to cos theta. Minus 1 by 2 is equal to 0.5, so cos theta is equal to minus 0.5. Now we are calculating the value of theta, so taking the cos inverse of this, we get theta equals to 120 degrees. So we see that this angle between f1 and f2 is going to be 120 degree, right? So this was which we have to calculate. Now coming towards the assignment 2.3, we are having the question that two forces are given. One is along x-axis, and obviously having an angle 0 degree. Another force is at 120 degree to that force. Then now we have to calculate the resultant and the equivalent force as well. Equivalent force is that force which basically balances the resultant force, or you can say it is an opposite direction to the resultant force, or you can say that it balances the sum of the forces on one side, right? I have to calculate FR and FE both. In that sense, first we need f1x, and then um, I will calculate the value of it. It would be f1x equals to f1 cos theta 1. Putting the values, we get 20 newton. Then f2x, we get the value minus 5 newton. Calculating the x components, adding up, we get 15 newton. Then f1y 0 newton. Then f2y to be 8.66 newton. Then summing up both, we get 8.66 newton. Taking out the um, magnitude of these two forces, what we get as a resultant, 17.32 newtons. And then to calculate the theta r is equal to 10 inverse of 8.66 divided by 15, we get the answer to be 30 degree. Now we see that the vector is basically um, uh, lying in the first quadrant, so this theta r would be equal to theta, so we don't need to use the equation. So this theta r is equal to theta. Now coming towards the fact that what would be the direction of fe. Obviously the direction of fe would be in opposite to fr, because it is balancing the force, balancing the resultant force. So fe would definitely lie in the third quadrant. And for the third quadrant, we do have, like in this case, as you can see, fr in this particular direction, then fr, which is the balancing force, would be in the completely opposite direction. So equation for fe would be equal to theta equals to theta plus 180 degree, and the value of theta was 30 degrees, so putting the value of this plus 180 degree, obviously, so we get theta e to be 210 degrees. So as you can see in this figure that we are having 180 degree plus this 30 degree, we get the result equals to 210 degrees, since we know that the magnitude of fr is equal to the magnitude of fe. So we have calculated the angle and the magnitude of the equivalent force as well. Okay, so all of the exercises, the assignments and the extension exercises and the assignments have been solved. So thank you so much. Allah Hafiz.